Hello everyone, this is a video recording for the quantitative ability section of the TCS exam. This is the part 1 of the recording which I am doing it today, and the second part I'll record it tomorrow. Let's have a look at the first question over here, which seems to be very interesting. Now what does it say? It says there are 3 ants that are sitting at the 3 corners of an equilateral triangle. Each ant starts randomly, picks a direction and starts to move along the edge of the triangle with the same speed. Okay, so what is given? Let's talk about it first. Let me draw an equilateral triangle. There are 3 ants who are sitting at the corners. Now what else has been said? Each ant starts randomly, picks a direction and starts to move along the edge of the triangle. Now, if I focus on this ant, now this ant can move along the edge of the triangle in this direction, or she could have picked this direction. Now, for the reference, I like to call this direction for this ant as clockwise direction. And thereby, if the ant goes in this direction, I'm calling it anti-clockwise direction. Okay. So this is the same for all the ants. Now, if this ant is going in this direction, I'll say, okay, the ant is traveling anti-clockwise. And if the ant happens to go in this direction, the ant would be traveling clockwise. If I draw for this ant, this is anti-clockwise. And this would have been clockwise. Now, so the question says the ant could have chosen any direction and they are moving with the same speed. Now let me read the entire question. What is the probability that none of the ants collide? Okay, so let me have a look at this situation. When will the ants not collide and when will the ants collide? Let me focus on this ant and this ant at the moment. Now, if this ant is going in a clockwise direction, it would not collide with this ant if this ant is also going in the clockwise direction. It has been said in the question that they are traveling with the same speed. That means they would not overtake if they are going in the same direction. So there is no possibility of a collision if they are going in the same direction. Now, thereby, the collision can only happen if this ant was going in clockwise, but this ant was going in anti-clockwise direction. Now, one thing from this I get to know is the ants are not going to collide if they are going in the same direction, whether it's a clockwise or whether it is anti-clockwise. And there will be a collision if they are going in opposite direction, as in if one of them is going clockwise and the other is going anti-clockwise. So, okay, now what is probability of an event? We all know probability of an event has to be favorable outcomes over total outcomes. Now, with regards to favorable outcomes, what I have ascertained at the moment till now is there are 2 favorable outcomes. One, if all the ants were going in clockwise, and the other, if all the ants were going in anti-clockwise direction. So there are 2 favorable outcomes. Now I need to figure out what are going to be the total outcomes. Now to figure out what is going to be the total outcomes, I'll treat the question as in we do a digit problem. Let's say I have a 3-digit number. So keeping the same reference, I'll talk about it here. For this ant, let me number them 1, 2 and 3. For ant 1, I have 2 options. An ant 1 could have gone in anti-clockwise direction or a clockwise direction. So how many options? 2 options. Now, with this ant going in either of the direction, for the second ant now, again I have two options, anti-clockwise and clockwise. So two options for this. And for the third, it remains the same. And again, I'll have two options. So to sum up, what are my total outcomes? This first AND has two options, and the second AND at the same time has two options, and the third AND at the same time has two options. So 2 into 2 into 2 has to be 8 options in all. So my total outcomes over here, I can say in the denominator has to be 8. So probability that they would not collide, favorable outcomes were when they were traveling in the same direction. One, when they were all were going in clockwise, and second, when they were all going anti-clockwise. So my probability they will not collide has to be 2 over total, that is 8, and my answer has to be 1 by 4, which is the B option. The second question is also very interesting on speed, time, and distance. Now, what does it say? It says there are two trains, A and B, and they happen to leave stations P and Q simultaneously and travel towards Q and P respectively on the same route. After meeting en route, A takes 1 hour to reach Q and B takes 4 hours to reach P. Finally, they say, how long did A take to cover the entire distance? So let me draw it over here. What is given? It talks about there are two trains. Okay, this is my train 1, A, and this is my train B. Now, they happen to move in opposite direction, and as a result, they happen to meet somewhere over here. Now, what has been said in this question is once train A and B meet, from that point, train A is going to take 1 hour to reach the destination, and for train B is going to take 4 hours to reach its destination at the opposite end. Now, the question sometimes seems to be little confusing. The problem is because our mindset is such, and what they are trying to highlight over here is what happens after they met. So they're trying to highlight, they're trying to give numbers, they're trying to give data, what happens after they have met. But it's going to be more easy to solve. It is going to be like easier to solve if we try to think what happened before they met. So keeping this thing in mind, I'll assume let T was the time from the start till they met. So what is the distance, let's say, covered by A? So if I get to know the distance covered by A, I'll say, okay, let's say the speed of train A is SA, and in T time, that is going to be the distance covered by train A. Now, similarly, I could have said if SB is the speed of B, and in T time, it is going to give me, when I multiply SB into T, it should be the distance covered by B. It is going to be the distance covered by B. Now, what is given in the later part of the question is after they have met. After they met, A takes 1 hour to complete the entire distance left over. So what is the distance left over is the same what was covered by B before they met. So what was covered by B before they met is this. So if I divide this distance by the time, that is 1 hour, which the train A is taking to reach the destination, I'll get the speed of A. And this is going to be my equation 1. Now, similarly, I would say this distance was covered by A before, and now it is going to be covered by B. So this distance, it is going to be covered in 4 hours at a speed at which B is moving. So this is going to be my equation 2 over here. Now, if I substitute the speed of A, if I happen to substitute the speed of A over here in this equation, I'll just write this SA can be substituted like this. And I can write it over here, and this speed of B is going to cancel on both the sides. And I'm going to get T square is 4, which is going to give me T as 2. So what does this mean? This T as 2 is, what is T? I took T to be the time from the start till they met. So if, let's say, I want to answer the question now, it says how long A will take to cover the entire distance. So what has A done? A has taken 2 hours to cover this much distance, and 1 hour more is going to be required by A to cover the remaining distance that was given in the question. So total time A would have taken to cover the entire distance on its own would be 3 hours. That is going to be my option D. Okay, keeping in going with the interesting question, now we have a question on time and work. What does it say? It says A plus B, A and B as a team can complete some work in 6 days. In how many days they alone can do the same work if A and C, another team, can complete the same work in 5 by 2, that is 2.5 days lesser than a team which has B and C together. What else is given? They together complete the work in 5 days. So once I'm reading the question, I was comfortable with reading the first line till the comma. And then there was a slight confusion if I'm reading it when it mentions A plus C can complete the same work in 5 by 2 lesser than B plus C. It seems to be a little awkward. But again, I believe you would be comfortable reading the last line. So they together can do it in 5 days. So how will we approach this question is, whatever simple things are, I'll work with the simple things first and then try to think about what little bit of a complexity is given in the third line. Okay. So let me just work on what is given over here at the first line and the last line. The first line says A plus B can do the work in 6 days. Okay, so let me just put it in short like this. A plus B requires 6 days to complete the work. And together would mean if they were working all of them together, they can do it in 5 days. Now, what do we generally do with questions on time work? We take the total work, as the LCM of this 6 and 5. So what is going to be the LCM of 6 and 5? LCM of 6 and 5 is going to be 30. So I'm assuming the total work to be 30 units. Now, so if A plus B can do it in 6 days, that is A plus B can do this 30 unit work in 6 days. So that means they are doing 5 unit work in a day. And together, when A plus B plus C is working together, they can do it in 5 days, means they are doing 6 units of work in 1 day. So if I just compare the two, there is only one difference, that in the second thing, C is also involved. As a result, I can say C can do 1 unit work A per day. So what do I have till now? A plus B can do 5 unit per day and C can do 1 unit per day. Now, keeping this thing in mind, now I read the third sentence, which seems to be a little complex. It says A plus C can complete the same work in a few days lesser than B plus C. Now, what is with this thing is, I tend to make an equation, but if I tend to make an equation, there is going to be like the solution is getting little complex. Instead, I will try to plug in the values, try and hit and try method. If it succeeds, it's fine. If it is not, we'll try to change the values. Now, if I read the third sentence once again, it says A plus B can do the same work in lesser days than B plus C. So let's say if I'm talking about A plus C and I'm comparing it with B plus C, the only difference between the two teams is, you can say C is common in both, and it is because A and B, they differ. And certainly when it says A plus C can do in same work in lesser days, that means A plus C is more efficient team. Now, if A plus C is more efficient and both the teams have C in common, so that means A is more efficient than B. Now, coming back to this, that what do we know? A plus B can do it in 5 days, and we know A is more efficient. So as a kind of hit and try, I'll assume A plus B can do it in 5 units together. So I'm saying, okay, A is more efficient. Let me take A can do 3 units. And B, to sum up to 5, I'll say, okay, B is doing 2 units per day. Now, if let's say I try to incorporate the C thing as well, C is doing 1 unit of work, and C over here will also do 1 unit of work. Now, total work, we assumed it to be 30 units. So if I'm looking to this team, they are doing 30 units of work, doing 4 units per day. So 30 by 4, that should be 7.5 days they would have taken. Now, if I do the similar thing over here, 30 units of work, if I divide by 3, that is the total unit B plus C is doing, what I have assumed they were going to take 10 days. Now, what do I realize now? That exactly it is matching with what is given in this question. So whatever the possibility of hit and try, we assumed it did work. It got validated. So I can say it this way: A is doing 3 units, B is doing 2 units, and C is doing 1 unit if I took the total units to be 30. Now, what is asked in this question is how many days they alone do the same work if they were working alone. So 30 units of work, if A was doing alone, 3 units per day, so A would require 10 days. Similarly, if B is doing 2 units per day, B is going to require 15 days, and C is going to do 1 unit, so C is going to require 30 days. So the option saying this would be my answer. Okay, let me read the next question. It says, in a certain flight, 3 by 4 of its seats were booked, including 2/3 of the business class seats. If 3 by 5 seats are business class, then what percent of the seats that were not booked were business class? Okay, they're trying to make a kind of a very confusing problem over here. So let's go step by step, I would say. First thing, what are the fractions given? Let me write it. 3 by 4. Without reading much, I happen to write the fractions. These are the fractions. I'm not worried what is given in this question. Now, I need to assume the total seats to be something. I could have taken it to be X, or I could have chosen it to be a number. Okay, so I'll take it to be a number, and specifically I'll take it to be a number which is the LCM of the denominators. So what is the LCM? You can say of 3, 4 and 5. 3, 4 and 5 is going to be 60. So I'll assume the total seats to be 60. Okay. So let me make a small table kind of a thing which is going to be useful over here. Okay, what is the kind of a division they are making with regards to seats? Now it says some of the seats were booked, so other were not booked. So can I just put it like this? Some of the seats were booked, so other have to be they were not booked. Okay, this is a kind of a division I'm making. What does it mean in this table? Total booked seats, I'm going to write it over here, and total not booked seats, I'm going to write it over here, and they should sum up to my total seats, which are 60. Other, you can say the division they are making is based on whether the seats were business class or they were not business class. So I'll draw another line over here, and I'll say, okay, some of the seats were business class, and some of them were not business class. Okay, so total business class seats would be over here and total not business class seats would be over here, and when I sum them up, they should also come to 60. Now at this point of time, I'll start reading my question again. It says in a certain flight, 3 by 4 of its seats were booked. So 3 by 4 of its seats means the total seats over here. So 3 by 4 of 60 would mean 45 seats were booked. So total I can say 45 seats over here, 45 seats over here were booked, which means not booked would be 60 minus 45. So 15 seats were not booked. Now, if I read the entire first sentence now again, it says in a certain flights, 45 of its seats were booked, and this 45 included 2/3 of the business class seats. Okay. Do I know what is my business class seats at the moment? I don't know. So I read further. Next sentence says if 3 by 5 of its seats were business class. So now he's going to give me how many business class seats are there. So let me just mark it. 3 by 5 of the total seats are business class. So 3 by 5 of 60 would mean 36 are business class. So now I'm going to write 36 are business class. So that would mean how many are not business class? That would be 60 minus 36. That is going to be 24. Okay. Now I go back to the second sentence once again. It said 45 seats were booked, which included 2/3 of the business class seats. So now I know how many business class seats are over there. There are 36 business class seats, out of which 2/3 were booked. So 2/3 of 36 would mean it is going to be 24. And once I have 25 over here, I just need to complete the table. Now this is the usefulness of the table. Once you get one value, you'll get the other values quickly. As in 24 plus something over here made it 45. So this something has to be 21. Now 24 plus something over here will make it a 36. So this something has to be 12. And 21 plus something over here has to be 24. So this something over here is 3. So once my table is complete, now I need to answer the question. Let me read it once again. Then what percent of the seats that were not booked were business class? So what percent of the seats that were not booked were business class? So not booked were 15, and out of those 15, 12 were business class. So what percent is 12 on 15? You can say it is 4 on 5. 4 on 5 would mean it is going to be 80%. 80% would mean C is going to be my right answer. Okay, the next question. So the next question is, I would say, the most interesting and the most challenging one for this part of the video. Okay, what does it say? It says x is the smallest number which when multiplied by 2 becomes perfect square, multiplied by 3 becomes a perfect cube, multiplied by 5 becomes a perfect power of 5. You need to find the number of factors of x. Now, initially, once you start reading it, you would say why you are saying it's the more challenging one with regards to this video, because it seems to be very simple. But as you start reading it and try to focus on it, you'll realize it is somewhat tricky, and that is what we need to take care over here. Okay, so once I've read this question, you would agree with me. I get to know that 2, 3 and 5 are basically the factors of the number. So the number have 2, 3 and 5 in it for sure. Now once let me read it again. Now this when multiplied 2 by 2 becomes a perfect square. So it would require a 2 to become a perfect square would mean 2 was raised to some power like 2k minus 1. 2k minus 1 where k is an integer. Okay. So 2k minus 1 would mean whenever I multiply with 2, it is going to become, the power is going to become 2k, and thereby it is going to become a perfect square. Similarly, I read over here for 3. Now when multiplied with 3, it becomes a perfect cube. So similarly, I can write it is of the power 3k minus 1. And similarly, I can write it for 5 that it is of the power 5k minus 1. Now, this is the primary thing what we have done. Now, once again I start focusing in it, I would realize something more. Now, what is that something more? When multiplied with 2, this is going to become a square. This is going to become a square means the remaining part was a square on its own. Let me repeat it. This when multiplied with 2 would become a square means the remaining part, this was a square from before. So what does it mean? This power of 3 is of the form 3k minus 1, but besides it, it is a power square. So what does it mean? It is of the form of 2k as well. And similarly, this power of 5 is 5k minus 1, but it is a square as well. So it is also of the form 2k. Now, coming back and reading the second line now, it says multiply by 3, it becomes a perfect cube. So what do we know? There was a deficit of a 3 over here for which we wrote 3k minus 1. But the remaining, which is this, is also a perfect cube on its own. So this power of 2, which was 2k minus 1, is also a power which is a cube form, which is like a 3k form. And similarly, I would say 5 is also of the power 3k. Now, coming back with the same logic, and I read the third line, it says multiplied by 5, it becomes a perfect power of 5. So this is, I require a 5 over here, but the remaining, this remaining was also a power of 5. What does it mean? This 3 is also a power of 5, and this 2 is also a power of 5. Now, let me go step by step now. Now, what do I know with regards to this 2? This is of the power 2k minus 1 and as well as 3k and 5k. Now, if it is of the form of 3k and 5k, so it means it is raised to power like in multiples of 5. As in, I'm going to take the LCM of 3 and 5, that is going to be 15. So it is a power which is moving as in multiples of 15. Multiples of 15 would mean 15, 30 and 45 and so on. And I need to keep the power less because I am looking forward for x being the smallest number. So I need to look at these multiples as well as I should combine, as in it should be of 2k minus 1 form, which means it is going to be an odd power. Odd power and minimum, and in this multiple of 15 has to be 15 itself. So one thing I know, 2 was minimum, it was raised to 15. Similarly, I would start looking for 3. Now, 3, if I happen to look at these two, 5k and 2k, so what do I realize for 3? 3 was moving in powers of 10. That because 10 is going to be the LCM of 5 and 2. So it has to be moving like 2, 10, 30, 10, 20, 30 and so on. And these powers should also be of the form 3k minus 1. So 10 is certainly not 3k minus 1. But if you happen to look at 20, 20 is of the form of 3k minus 1, whereas you can say 3 into 7 is 21 minus 1, that is going to be 20. So this has to be 3 raised to power 20. Now coming to 5, 5 is already, you can say it is moving in the powers of 6 because 3 and 2, the LCM has to be 6. So multiples of 6 would look like this, and these multiples should also take into account, it is going to go like till 24 and 30 and so on. This should take into account, this should be of the form 5k minus 1. So certainly 6 is not of the form 5k minus 1, 12 is not of the form 5k minus 1, but when you happen to look at 18, again it is not, but when you happen to look at 24, it is of the form 5k minus 1 because 5 into 5 is 25 minus 1 will make it a 24. So this is going to work. Now, once we get the powers over here, how do we find number of factors? let's stick to basic. Number of factors over here would be, I increase them by 1. I'll say 16, 21 and 24, 25. So my number of factors, the answer has to be 16 into 21 into 25, and that is going to be my right answer. With this, we end the part 1 of this video series on quantitative ability for TCS. We'll record a video for part 2 tomorrow. Thanks for watching the video and best of luck for your exam.